So it looks like there's only one word problem. This is the walker-runner word problem. One person runs 1 mile per hour slower than another. The faster runner can cover 20 miles in the same time the other runner can run 16 miles. So you have to remember we did these with a box. And in the far left column we had the names in some sense. And the names I'm going to have are just the fast runner and the slower runner. That's one of the easy parts of the box to get. And then we have distance, speed or rate, and the time is distance over rate. So the distances are easy. The faster runner can go 20 miles, so in the distance box for the faster runner, I put 20. In the same time, the other, which I'm assuming is the slower runner, can cover 16. The X's go in the rate, and in this walker-runner problem, only one of the rate boxes is in the X, the other one has a sign. And in this case, the slower runner is going to get the minus sign, and in for the rate of the slower runner, because it's 1 mile per hour slower than the faster runner, I'm going to make the slower runner's rate X minus 1. And in these walker-runner bike problems, only one of the rate boxes gets a sign, unlike the boat problems where they both get a sign. Once you get the first two boxes done, you're done, because now the last box, time is distance over rate. So the time box for the faster runner is going to be 20 over x. The time box for the slower runner is going to be 16 over x minus 1. In this case, x is the speed of the faster runner, because that's where the x at. It's in the rate, which is speed, of the faster runner. So I'm going to set these equal to each other because they're running for the same amount of time. So I set the time boxes equal to each other. That's how we did every one of these problems earlier in the semester. And we solved these by cross multiplying. So I'm going to cross multiply down and up. When I cross multiply down, I get 20 times x minus 1. When I cross multiply up, I get x times 16, which I write 16 times x. No squares here, so they're not so bad. The left-hand side, I clear the parentheses. I go 20 times x is 20x. 20 times minus 1 is minus 20. There's no squares, so I don't have to set it equal to 0. I'm going to minus 20x from both sides. And that will give me minus 20 equals to minus 4x. And then I'm going to divide both sides by minus 4. I can do these things in my head. On the left side, the double negatives turn to be a positive, and 20 divided by 4 is 5. And on the right side, you're left with an x. That's not enough because I need to write the speed of each runner. The faster person is x, or 5 miles per hour. The slower is 1 mile per hour slower. 5 minus 1 is 4. So for my answer, I'm going to write the fast is 5 miles per hour, and then I need to subtract 1 for the slow, and the slow is 4 miles per hour. Once you get the number, it's easy to tell what it's meant for. It's meant for the rate box without the plus or the minus, so the x stands for the faster runners, and then I subtract 1 to get the slowers. Alright, the only word problem in the whole review, we're done with it. Alright. 24, when you multiply 2 fourth roots, you get another fourth root. So on 28, should I say. So when I do the multiplying part, I'm going to make the two radicals down to one radical. I'm going to put the a's next to each other and the b's next to each other. And the first b has an implied exponent of 1. I'm going to now make the two a's down to a single a and the two b's down to a single b by adding their exponents. And any time the exponents are divisible by the index, you can drop the radical symbol by just dividing the exponent of each letter by the index. So the exponents on both the a and the b are 4, and I'm going to divide them both by, or 12. I'm going to divide them both by the index of 3. And my answer to 28 is going to be a cubed, b cubed. That's as easy as we get. 29 I could do on my calculator. I don't have a problem with you doing the problems on your calculator that you can. I'll do this by hand. I need to reduce 18, and I'm using my calculator to do that reduction anyway. So I'm going to reduce the square root of 18. If I'm going to use my calculator to do any reducing, I'd do the whole thing on my calculator. But the square root of 18 can be rewritten. So I can make this 5 times 3 square root of 2 by reducing the square root of 18. And now I'm going to reduce the square root of 50. The square root of 50 is 5 square root of 2. So this is going to be 3 times 5 square root of 2. So now I've done double reducing. I reduced this radical and that radical. And now I'm going to do the multiplying that's implied. The first multiplying is going to give me 15 square root of 2. Also, the second multiplying is going to give me 15 square root of 2. So when you're adding with radicals, you just add the numbers in front of the radicals and leave the radicals alone. And you can only add if they have the same numbers under the radical. Of course, I could have just did this on my calculator, did 5 square root of 18 plus 3 square root of 50, and I'd get that answer. Of course, you might run across somebody in college algebra that doesn't let you do that, so be able to do something by hand. 30 is a foiling problem. Let me just FOIL it out, and then I'll do it on my calculator. So the firsts in 30 are 5 square root of 3 times 4 square root of 3. I multiply outsides by outsides, unders by unders, so I multiply the 5 and the 4 and get 20, the 3 and the 3 and get a 9. Outers are 5 square root of 3 times minus square root of 2. The only thing I could have to multiply there are the 3 and the 2. They turn into a 6 and they stay under the radical. Outside the radical I have a 5 which needs to stay there, and I'm multiplying a positive times a negative, so I should get a negative. For the inners, 6 square root of 2 times 4 square root of 3. I multiply outs by outs. 6 times 4 is a positive 24. Unders by unders, 2 times 3 is a square root of 6. And then lasts, 6 square root of 2 times minus square root of 2. The 6 times the minus, it's really 6 times minus 1, so you get a minus 6. And then 2 times 2 for the unders are square root of 4. Almost done. These are going to combine. The numbers in front of the radicals have opposite signs. 24 minus 5 is positive 19. And those two are going to combine to positive 19 square root of 6. The firsts is 20 times the square root of 9, but the square root of 9 is 3. So that's really 20 times 3, which is 60. The lasts are minus 6 times the square root of 4, but the square root of 4 is 2, so that's really minus 6 times 2, which is minus 12. Last up goes 60 minus 12 is 48. And my answer to problem 30 should be that. And let me double check it, because I certainly can do this really quickly on my calculator. So on my calculator, I'd go 5 square root of 3, plus 6 square root of 2 times 4 square root of 3 minus square root of 2. Hopefully I get exactly that. Hopefully I enter it right and get exactly that. So 48 plus 19 square root of 6, I'm spot on. I'm wearing out, so hopefully you aren't. 31 has a square root and an equal sign. I need to get rid of that square root. To get rid of square roots, you square. So I'm going to square both sides. And on the left side, squaring leaves me what's under the square root without changing it. It just crosses out the square root symbol. On the right side, 8 squared is 8 times 8, which is 64. Now I'm going to minus 2 from both sides. I have a problem that doesn't have a square. I just solve it like a regular Math 092 problem. So that gives me minus 5x equals to 62. I divide both sides by minus 5. And there's lots of ways I can write my answer for this problem. I can write x equals 62 over minus 5. That's probably the strangest looking answer, but it's completely fine. That negative sign can be moved up into the numerator next to the 62, or it can be written to the left of the fraction. But this would be okay, but it probably would be better if I did something different with that negative. I always I tend to bring it up to the numerator, but you can definitely just write it to the left of the fraction as well. But as long as you had the fraction 62 over 5 with a negative sign somewheres, whether it's in the denominator, in the numerator, or kind of right to the left of the fraction, it's all okay. 32 is much worse. 32, the left side is about the same, but the right side, I have to square it, and the squaring is kind of nasty. In 32, I'm going to take the time to check my answers, because generally this kind of problem produces a solution that doesn't check. I haven't been checking too much because, again, it takes so much time. I'm only going to check when I absolutely have to. And this one I'll have to. So on 32, on the left side, I'll square it just like I did on 31. And that will leave me with 2x minus 3, which is a good thing. On the right side, I'm squaring x minus 3, and I have to do that by foiling. And so I'm going to rewrite the right side without the exponent. I'm going to write it with 2x minus 3's. And I'm going to do firsts, or x times x, which are x squared. Outers are x times minus 3, which is a minus 3x. Inners are minus 3 times x, which is a minus 3x. Last, minus 3 times minus 3, which are a plus 9. So when I FOIL out that right side, the outers and the inners have the same signs. They only cancel when they have opposite signs. They have the same signs. You add the numbers and keep the signs. I'm going to add the 3's and keep them negative. So now I have the problem FOILed out. There's an equal sign and a square. Generally, when that's the case, you set the problem equal to 0 and factor. So I'm going to minus 2x and plus 3 from both sides. I'm going to get 0 on the left side and x squared minus 8x plus 12 on the right side. Now I need to factor. That's a double minus on my factoring. And my last have to multiply to 12 and add to 8, and that's going to be 6 and 2. Now that I have it factored, I'm going to split each factor up and set each one equal to 0. So I'm going to go x minus 6 equal to 0, x minus 2 equal to 0. For the x minus 6 equal to 0, I'm going to add 6 to both sides and get x equal to 6. For the x minus 2 equal to 0, I'm going to add 2 to both sides and get x equal to 2. If I don't check, I wrote down 6 and 2, I'm probably going to lose some points. So the original problem is the square root of 2x minus 3 equals x minus 3. To check the 6, I need to see is the square root of 2 times 6 minus 3 equal to 6 minus 3. And to check the 2, I need to see is the square root of 2 times 2 minus 3 equal to 2 minus 3. So for both of these, I'm just plugging in the number for x. This one I'll do on my calculator. So I'll do the square root of 2 times 6 minus 3. That gives me 3. And the right side, 6 minus 3, I can do in my head. That's 3. For this one, I'm going to do the square root of 2 times 2 minus 3, and I get 1. And for the right one, I do 2 minus 3 and get negative 1. 2 is not a solution because it doesn't produce a true statement when I plug it in. So the only answer is the 6 because it's the only one that gives me a checking that works. So my answer to number 32, and you can't see the 32 anymore, is x equal to 6. I think there's another problem coming up that also you get a non-checking answer that you have to do the checking. And I'll only do the checking when I'm absolutely certain it has to be done. If you're taking the final and you're confused on whether you have to check or not, either just go ahead and check everything or come up and ask me and I'll tell you if it's one you have to check or not. For 33, to get rid of squares, you square root. When you square both sides, because if you square a negative, it goes positive, you don't need a plus or minus. But when you square root, you need the plus or minus. So on the left side, square rooting cancels out a square, just like squaring cancels out a square root, makes it so I don't need the parentheses anymore on the left side. And on the right side, I want to reduce the square root of negative 18. And I'll just cheat. I'll do square root of negative 18. And I get 3 radical 2i with that plus or minus sign. I'm almost done. I just need to solve for t. I'm going to minus 5 from both sides. And then these terms can't be combined because the 5 doesn't have a square root of 2, nor does it have an I. So this is going to be my answer, and my answer is going to have that plus or minus sign in it. All right. $14.34 wants me to use a quadratic formula. Why did I? Let me change these to x's. I don't like having a quadratic formula problem that has an x in the problem or a b in the problem. That's a dumb way to write the problem. So I just tweak the problem. It's the same problem, but it doesn't have b's, which are just stupid. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. We basically did these on our calculator. The a is going to be the 5. The b is going to be a negative 14 because it's negative. It's going to need to be in a parentheses. And my c is going to be negative 3. So I'm going to write x equals negative 14 plus or minus the square root of negative 14 squared minus 4 times 5 times negative 3 all over 2 times 5. I'm going to enter all of this, but I can't do the plus or minus sign, so I'm going to do the plus sign. And quite honestly, I could probably enter that as a positive 14 because that double negative turns positive, and it's just one less thing to enter. So I'm breaking out my calculator. So the best I can now. Clear fraction 14 plus square root parentheses negative 14 squared minus 4 parentheses 5 parentheses negative 3 all over 2 parentheses 5. If my answer comes back with an I or a square root, then I'll just take that answer and change the plus sign to a plus or minus sign. If that answer comes back and it doesn't have a fraction, if it doesn't have an I or a square root, I need to do the minus part. Ooh, and I get 3. So that's one of the answers. That's the answer for the plus. To get the answer for the minus now, I'm just going to use my back arrow. And I'm going to go through and get into the problem. I get right to where I entered that plus sign where I had the choice of the plus or minus. I hit my delete key, type the minus key. That's the minus part of the plus or minus. And now I hit enter and get the next answer of negative 1/5. So the answer to this using the quadratic formula is x equal to 3 and x equal to negative 1/5. Had my first step had an I in the answer or a square root in the answer, I wouldn't have had to go backwards and make the plus into a minus. I could have just taken that plus sign and changed it to a plus or minus and been done. All right. For 35, this is the other problem on the test where you're going to have to check your answer if it comes up. And both problems that need checking, what they have in common is they start with a square root, and I'm squaring to get rid of a square root. And what they're going to have in common is somewhere there's a letter that's not under the square root. So 35, I need to square to get rid of the square root, and there's a letter that's not under the square root, just like in 32. I have to square to get rid of the square root, and there's a letter that's not under the square root. That's the situation that causes me to square both sides. So let me get this problem going. I want to make it so I can square both sides easily. So I have to minus p from both sides. And this is the best I can do in terms of getting the problem ready to square. Now I'm going to square both sides to get rid of the square root. I treat the sides differently because the left side doesn't have a plus between the 3 and the square root of p. Then I can just square each piece separately. So I'm going to square the 3 and square the square root of p. Because there's a plus sign between the minus p and the 4, I can't just square the minus p and square the positive 4. I have to FOIL on the right side. On the left side, 3 squared is 9. And when you square a square root, the square and the square root cancel, and I just have a p there. On the right side, I do first, which are negative p times negative p, which are positive p squared. Outers are negative p times 4, which is negative 4p. Inners are 4 times minus p, which is a minus 4p. Lasts are 4 times 4, which is a plus 16. So I did first, outers, inners, lasts. On the right side, the outers and the inners don't cancel because they have the same signs. The outers and the inners, you add the numbers up and keep the sign. So I'm going to get 9p equals to p squared minus 8p plus 16. I need to set this equal to 0 because I have an equal sign and a square. I'm going to set it equal to 0 and solve by factoring, or the quadratic formula if you can't factor it. So this gives me 0 equals p squared minus 17p plus 16. If you can't factor this, use the quadratic formula to get this thing solved for. But for me, this isn't hard factoring. I'm assuming that you can do the quadratic formula without me showing you it. This factors into p minus 16 times p minus 1. Signs are minus and minus. Last multiply to 16, add to negative 17. Now that I have it factored, I'll set each factor equal to 0. For the p minus 16, I add 16 to both sides and get p equal to 16. For the p minus 1, I add 1 to both sides and get p equal to 1. Both of these need to be checked. I'm going to check them up top because I'm kind of running low on room. So I'm going to check p equal to 16. And then that I'd go 16 plus 3 square root of 16, and that would have to equal to 4. And then I also need to check p equal to 1. And to check p equal to 1, I'll go 1 plus 3 square root of 1 and see if that equals to 4. So I need to check them both. And so the first one, I'm going to do 16 plus 3 square root of 16. And that gives me 28 equal to 4. So 16 is not an answer. It shouldn't be part of my solution. And then 1 plus 3 square root of 1, that gives me 4 equals to 4. That needs to be part of my solution. So the only solution to problem 35 is going to be p equal to 1. So my answer for problem 35 only should include the number that checks, and that's p equal to 1. So there's only 2 problems on the entire review that you absolutely have to check, and they both have a square root that you have to square to get rid of the square root, and there's a letter that's part of the problem that's not under the square root. 36, I'm going to clear the parentheses. First parentheses, I'm going to FOIL. Second parentheses, it's really minus 1 times x minus 3. If you need to see a 1 there, it might help you clear that parentheses. So on my first step, I set this one up to clear the parentheses to indicate it's going to be a FOIL. I snuck a 1 in front of there because I have to multiply both things in the parentheses by minus 1 to clear that parentheses. So this parentheses, firsts are x times x, which is x squared. Outers are x times minus 3, which is a minus 3x. Inners are minus 3 times x, which is a minus 3x. Lasts are minus 3 times a minus 3, which is a plus 9. Next parentheses, I go minus 1 times x is a minus 1x. Minus 1 times minus 3 is a plus 3. I leave that minus 6, and I leave the equal to 0. So now I have the whole thing ready to combine. I'm going to leave the x squared alone, and I need to combine a minus 3x, a minus 3x, and a minus 1x. Each of these numbers have the negative signs. Add up the 3 numbers and keep them negative and get a minus 7x. And I also have a plus 9, a plus 3, and a minus 6. That comes out to 12 minus 6, which is a plus 6. So now I have it a square that's set equal to 0. I can solve by the quadratic formula if I don't know how to factor it, or I can factor it. And for me, it's not so hard to factor. I'm going to factor this. It factors into x minus 1 times x minus 6. I didn't explain the factoring because if you can't factor it, I expect to use the quadratic formula. And now I'm going to go x minus 1 equal to 0, x minus 6 equal to 0. For the x minus 1, you're going to add 1 to both sides and get x equal to 1. For the x minus 6, you're going to add 6 to both sides and get x equal to 6. And my answer is going to be x equal to 1 and 6. All right, I think we have like 7 more problems to do. 2 parabolas to graph, which for me are easy because I'm just using my calculator to generate the table. And then some problems with the exponents that we ended the semester on. All right, so for 37, when we have a graph of a parabola and there's a single x inside of parentheses, the table that we're going to get, we're going to take the number that's inside the parentheses and change its sign, find that number on the x-axis, go to the left a couple, and to the right a couple. So my starting table for this that I'm going to use to get my graph is going to have 0, 1, 2, 3, and 4 in the x column. And I'm going to use my calculator to generate the table just because it's so much easier. So I'm going to go mode 7 for table. Now I'm going to type parentheses and then alpha x minus 2 squared plus 3. Start at 0, end at, start at 0, end at 4, step 1. I'm going to steal my y's. So it goes 7, 4, 3, 4, and 7. And it has to have that happen. The y's need to repeat. So now I have my table. So I'm going to plot the point 0, 7. And then I'm going to plot the point 1, 4. And then the point 2, 3. So 2, 1, 2. You can barely see these very well. And then 3, 4, and 4, 7. So you can write the points down. So there's the point 4, 7, 3, 4, 2, 3, 0, 7. You don't have to write the points down. And so there's my graph. So this is sketching a graph. I'm supposed to say what the vertex is. The vertex is where the parabola bends, is at the point 2, 3. So part of my answer to problem 37 needs to say the vertex is the point 2, 3. And then the axis of symmetry always has the equation x equal the x coordinate of the vertex. So my axis of symmetry is going to be x equal to 2. And that's it for problem 37. For problem 38, it has 2 x's. So to get my table started, I need to use the formula negative b over 2a. That's going to be the number for the middle of my x column. In this particular parabola, the a is the number in front of the x squared. I don't see a number there, so it's implied to be 1. The b is the number in front of the x, which is 6. So this is going to be negative 6 over 2 times 1, which is going to be negative 6 over 2, which is negative 3. So my table is going to have a negative 3 on it, and it's going to go left a couple to negative 4 and negative 5, and right a couple to negative 2 and negative 1. So my x column is going to have, starting with negative 5, it'll have negative 4, negative 3, negative 2, and negative 1. Mode 7 for table, f of x equals alpha x squared plus 6 alpha x plus 10. Start at negative 5, end at negative 1, step 1. So next to negative 5 I get positive 5, next to negative 4 I get positive 2, next to negative 3 I get 1, next to negative 2 I get 2, next to negative 1 I get 5. So now I'm going to plot those points. Negative 5, and here's 5, so 1, 2, 3, 4. And there's negative 5, 5, and then negative 4, 2, negative 3, 1, negative 2, 2, and negative. I'm assuming you can plot these even though you can't see it so well. I'm plotting the points, you know, it's easy to do. You just can't see it so well. But you're going to be, they'll be easy to plot. So there's my graph, and I'm supposed to say find the vertex. I don't need the axis of symmetry. So the vertex is always in the middle of my table. So I'm going to say the vertex is the point negative 3, comma 1. That's it for 38. Just like 5 more problems to go. And they all involve prime factorings and exponents. So in problem 39, I need to solve by writing each side with the same base. 16, I can do a prime factor tree for it. 16 is 4 times 4, and each of the 4s are 2 times 2. So 16 is equal to 2 times 2 times 2 times 2. 16 is equal to 2 to the 4th power. So I can rewrite this problem, leaving the left side 2 to the x plus 5, changing the right side to 2 to the 4th. And once in each of the problems between 39 and 43, you have both sides with the same base. You solve the problems by dropping the bases and setting the exponents equal to each other. There's no squares. When I set the exponents equal to each other, I just need to isolate the x. And my answer for 39 is going to be x equal to negative 1. Forty's harder. For me, it's a lot harder. So for 40, 5 is a prime number. I can't do anything with a prime factoring for it. I can write the right side as 5 to the first. 125 is not a prime number. Remember how we did factor trees on our calculator? To do a factor tree on my calculator, I have to go mode 1, and then I can type in 125, then hit the equal sign, and then do shift, and then the quotes key. So 125 is equal to 5 cubed. Again, I hit the mode key, checked option 1, typed 125 and typed equals, and then shift in factor, and so 125 is 5 cubed. So the left side, I can think of this as 5 cubed to the x minus 4 power. Because the 125 already had an exponent, I probably should put the 5 cubed in a parentheses, because to simplify the left-hand side, I have to multiply the 3 by both the x and the 4. So I'm going to go 5 to the 3 times x and 3 times minus 4. So I multiply the 3 by the x and by the minus 4, and the left side becomes 5 to the 3x minus 12 equal to 5 to the first. Now that I have both sides with the same base, I drop the bases and I set the exponents equal to each other. For the left side now, I need to isolate the x. There's no square, so I don't have to set it equal to 0. I just need to get the numbers on one side, the letters on the other. I'm going to divide by 3. Obviously, I'm getting tired. Well, when you have 3x equal to 13, if you minus 3x, it's going to be stupid. I need to divide both sides by 3. And on the left side, the 3's will cancel. On the right side, I get a fraction that doesn't reduce, and that's going to be my answer to problem 40. 2 more. 25 is easy to do a prime factoring for. If I do 25 equals and do shift quotes, you get 25 is 5 squared. So I can write the right side with a base of 5. To get the left side with a base of 5, I have to know that 1/5 is equal to 5 to the negative 1 power. So I'm going to rewrite the left side without the fraction, making it have a negative 1 exponent, leaving it in the parentheses, and now I'm going to multiply negative 1 times 3x and negative 1 times negative 1 to clear that parentheses. Negative 1 times positive 3x is negative 3x. Negative 1 times negative 1 is positive 1. So now, with using my calculator or my brain to get the left side done, and some trickery to get the right side done is easy. The left side, I need the trickery. Now I have both sides written with the same base. If you can write both sides with the same base, you can solve the problem by dropping the bases and setting the exponents equal to each other. In this problem, I'm going to minus 1, and that will give me minus 3x equal to positive 1. And then I'm going to divide by minus 3. On the left side, I get just the x, and on the right side, I can leave that 1 over minus 3. I just don't like the minuses in the denominator. But wherever you choose to put the minus on the right side, you just need a minus and a 1/3 on the right side, and that minus can more or less go anywhere. And that would be the answer for problem 41. Just one problem left. On 42, I need a prime factoring for 27. So I'm going to go 27 equals shift factor. It's 3 cubed. I'm going to write this side as 3 cubed to the x minus 4, and 9, enter, shift factor. 9 is 3 squared. So this is 3 squared to the x. Now I'm going to multiply the exponent on the left side by 3. I'm going to go 3 to the 3 times x and 3 times minus 4. And on the right side, I'm going to clear the parentheses by multiplying the 2 and the x. So now I have 3 to the 3x minus 12 equals 3 to the 2x. Both sides have the same base, so now I can drop the bases and set the exponents equal to each other. There's no squares, so I get the letters on one side, the numbers on the other. I'm going to minus 3x from both sides. This gives me minus 12 equals to minus 1x. I need to finish this up by dividing both sides by a minus 1. On the left side, the 2 minuses cancel. I get a positive 12. Similarly, on the right side, the 2 negatives cancel and I get a positive x, and that's my answer to 42. That's the end of the review. So if you can do every problem on the review, you should be able to do every problem on the final. There are 42 problems on the review. You know, I can't imagine my final having 42 problems. Probably 25 to 30 problems will be what it has. So, but any problem that's on the review is legitimate for the final. So if you can do them all, you should be fine.